Okay, so the first part in gravitation is actually Newton's universal law of gravitation. Okay, Newton's universal law of gravitation. So this is the definition. But before we go into that, we are going to see this one first. So it is said that gravitational force is a universal force. Okay, so gravitational force is a universal force. So there are two reasons why we call gravitational force as a universal force. Okay, why is that? The first reason is because gravitational force acts between any two bodies in the universe. For example, here I give you three bodies. Okay, basically object. Okay, so we have object A, body B, and body C. So between any two bodies in the universe, for sure there will be gravitational force between them. So for example, A and B. Okay, two objects or two bodies in the universe can. So between them has gravitational force. So between A and B, there is gravitational force. So basically, okay, anything, any object between two objects, there must be gravitational force. Same goes with B and C. So between B and C, there is gravitational force. Okay. Between A and C also has gravitational force. Okay, for example, you are sitting on a chair right now. Okay, so between you and the chair, there is a gravitational force. Okay, between you and your phone, for example, there is a gravitational force. But why are you not attracted? I mean, like, why is the phone not attracted to you, or you are not attracted to the phone? Okay, it is because the force is very small. But the idea is there is force between two bodies. Okay, and the second point is both bodies experience same magnitude of gravitational force. So what does that mean? So it means that, by the way, magnitude is like number. Okay, the amount of something. So magnitude of gravitational force between two bodies are the same. Okay, but okay, you have to understand this properly. For example, gravitational force A is pulled by B and B is pulled by A. So these two force has the same value. So same value means that they experience the same magnitude. For example, A is pulled by B with a value or magnitude of gravitational force by 10 Newton. So B is pulled by A with also 10 Newton. Okay, let's say we change the situation B and C. So B is pulled by C, let's say this is just an example, 5 Newton. C is pulled by B, also 5 Newton. So this is important. When we say same, okay, we are not talking about everything also same. No, we are talking about that specific pair only. So between A and B, same. Okay, between BC, CB, same. Between AC, CA, same. So that is what we mean by both bodies experience same magnitude of gravitational force. Okay, so that is why we call gravitational force as a universal force. Okay, so that is done. Now we're going into the Newton's universal law of gravitation. Okay, so to understand this, I think it will be better if we just look at the formula of gravitational force. Alright, so this is the formula for gravitational force. This is the relationship lah. Okay, as you can see here, read first. Gravitational force is directly proportional to the product of masses of two bodies and inversely proportional to the square of the distance between centers of the two bodies. Yes, I understand. Okay, the sentence is very long. Okay, but it is not hard for you to remember because exam, the formula is given. So it is actually, you can see from the formula. So what I mean by that? So we know that gravitational force is basically the force, so it is F. Okay, product of masses of two bodies, basically M1 multiplied by M2, product kan? So it is product of masses of two bodies. And then square of the distance between centers of these two bodies. So distance between two objects is R. The distance between two objects is R. So square of that is R squared. So from there, we know that F is directly proportional to M1 multiplied by M2. Okay, so this is how you write directly proportional at the top. And at the same time, it is also inversely proportional to the square of the distance. So inverse means one is at the top, one is at the bottom. So from here, you get F directly proportional to M1, M2, inverse proportional to r squared. So from this, you can use constant and then you get formula. Okay, so do not worry about the gravitational constant. It is a constant. So it's given. And also, if you use your calculator, some calculator does not have this function. Okay, but you can use constant 39, and then from your calculator you get capital G. So that is your gravitational constant. So that is the value lah. Okay, for some calculators there are different ways. Okay, so you just have to try lah. Okay, on your calculator. Anyway, F equals to G m1 m2 over r squared, where F is the force or gravitational force between the two bodies. Okay, G is the gravitational constant given, m1 is the mass of the first body. Okay, m2 is the mass of second body. Okay, so we have two objects. This is m1, this is m2. Okay, so gravitational force is directly proportional to the product of these two masses, and then inversely proportional to the r squared, okay, which is the distance between the two centers of the bodies. Okay, so even though the sentence is very long, you can remember, okay, and you can use this formula, okay, to make sense of the sentence.